C++ STL vectors are an extension of the idea of arrays. Like an array, a vector contains a collection of objects. Unlike an array, vectors can contain more than one data type, and they can be resized. In the same way that array list class objects are sort of an extension of the idea of an array in Java, vectors are an extension of the idea of an array in C++. Now, vectors come from the standard template library, or the STL, and they utilize iterators, even though they do function like arrays. Also, vectors are constructed on the stack, but the objects they contain are on the heap. So they practice data hiding, and they sort of conceal the complexity of their innards, or how they work. And we've talked about linked lists before, and they sort of work like a linked list. So what we'll need for the project, IOStream because it's the console, string because we're using a string class object, and we'll need to use the vector or implement the vector header file because we're going to create and use vector objects. We're going to place ourselves in the standard namespace, and we're going to create a single class here just to be symbolic of a programmer-defined or user-defined data type or object. So it's just got a standard constructor and destructor that just displays a line of text in the console that we're building or destroying a Platinum Dragon. We have a display stats function which takes care of displaying the private data name and age. We have public get and set accessor functions to set that and get that data. As in the previous array example, we're going to have a global constant integer, size of vector, and it's going to have a value of 5, and it will not change. Now, here's the thing. One of the key differences between vectors and arrays is that once you build an array, it's not dynamic. You can't shrink the array or expand the array if you need to. The size is fixed. Now, that's not the case with a vector. With a vector, you can actually increase its capacity and grow it if you need to, expand it, or you can shrink it down if you don't need that much space and conserve memory. So in that aspect, it's a bit more dynamic than a simple array object. So we have several examples here, and they're prototyped, and we're going to go through and look at each one. How do you declare a vector, resize a vector? We'll look at some vector methods, and then we'll look at instantiating a vector on the heap and the stack, or heap free store stack, and just implementing vectors with pointers and things. Declaring vectors. Here are some useful vector methods. First, pushback, which adds an object to a vector, increasing its size. Second, insert, which inserts an object into a vector between specified points. Then there's size, which returns the number of objects in a vector. Empty, which returns whether or not a vector is empty. Capacity returns the capacity of a vector. Vector.begin is an iterator returning the beginning of the vector, and vector.end is an iterator returning the end of the vector. Let's take a look at our first method here, declaring a vector. And we'll just uncomment that and go look at the function definition. And here we're just going to display some text declaring a vector of integers. And this is an example of creating a vector of a specified size. So this is a vector of integers. Here's the data type. And we're specifying it's a vector of 100 integers. And here is an example of creating a vector of unspecified size. It's just a vector of integers, but we haven't specified any size yet. Either way, we'll pick this as an example. And let's say we just wanted to add some items to the vector scores. Well, we use the function pushback, and we'll add 100, 200, 300, and 400. So 4 scores to that vector. And it works much like an array, with the exception that there's a function called size that gives us the number of objects stored inside of the vector. And that's kind of cool because we don't really have an equivalent to that with a C++ array. Now in Java you do. In Java, even a simple array in Java has the length attribute, which will give you the number of elements in the array. And then of course the Java equivalent of a vector is the array list class object, and it has the same function, size. But in C++, there isn't a length attribute. There is getLength that you have with strings, but as far as just a plain old array, no. So that's kind of a neat feature in C++. When you use a vector instead of an array, you have the size method. And that way you can make your code more dynamic, because as your vector expands and contracts to hold more objects or consume less memory if you don't need to, to hold objects, and you remove some, then size will return the different values as they change. And you don't have to worry about, using, uh, you know, uh, hard-coded values or constants or anything like that. So that's kind of a cool feature. I like that size method. And pushback just to add items in. And here we're just going to display it. And notice that, it looks just like an array. So you have the square brackets, and you would use x, in this case, as a subscript value, or whatever you're using as a counter inside your repetition structure, the for loop. And that would display all the elements in the array. So let's see how that looks. If we run it, we'll build the project. And we'll run it. And as we go through each object stored inside of our vector, position 0 through 3, remember that it's off by 1, just like an array. We humans tend to start counting at 1, but arrays and vectors, they start counting at 0. So 0, 1, 2, 3, which would be elements 1, 2, 3, and 4. And here are the values stored there. And again, I'm just going to make this possibly easier to see. We'll do black text on a white background. Resizing vectors. Let's take a look at our next example. So we're just going to comment out declaring a vector, and we'll uncomment resizing a vector. So if this was declaring a vector, both a vector of fixed size and a vector of an undetermined size, let's look at resizing a vector. We're going to make a vector, and again, this time it won't be a vector of fixed size, but a vector that we're going to add 4 squares to. So the first time through, when we call our for loop and display the items there, size is going to return the value 4. 0, 1, 2, 3, but 4 elements or objects inside the vector. Okay, and we're just going to pause, and we'll clear the screen. And now we're going to resize the vector by removing 2 scores. And to do that, we'll use the method erase. All right, that's a vector class method. And it accepts as arguments iterators. So we can call squares begin, which will give us basically 0. That would be like index or subscript value 0 in an array. And then that's the start position, and then the end position is what we want to remove to. So if that was it, I could just use squares begin. But if I do squares begin to squares begin plus 2, then this is going to go 0 and 1. So in this case, I'll end up removing the first 2 scores there. And then I'm going to call a loop to display it again. And this time, instead of rendering 4, the size method, when we invoke it or call it, is now going to render 2. And we'll simply display 2 scores. And now, then we're going to go through, we're going to pause, and we'll clear the screen again. Now we're going to remove the remaining squares using begin and end. And this is just showing you how to access, if I don't want to go all the way to the end, let's say I just wanted to get 2, I could use scores.begin, and then scores.begin plus however many I wanted to go to. But in this next example, I'm using 2 iterators, these methods here. So the beginning of the vector all the way to the end of the vector. Effectively, that's just going to clear the whole thing. And if I display it, now there's really nothing to display. Size is going to render now a value of 0. Okay, now here I'm going to add scores back with insert. And the way this would work is you can insert from the beginning or from the end. But if I want to do 100, 200, 300, and 400 respectively, and do it in order, I want to start at the end. And I've put the arguments here, but if you look at the parameters of the arguments, the first one is the iterator, where to insert. So if I insert from the end, then I'll sort of pop the other ones on top there. And then the second argument is the number of times to insert. I only want to insert them 1 time. I don't want to insert these values more than once here. But if I did, I could modify that. Let's say I wanted to insert the 205 times. I could just make that middle argument 5. And then the last is the value, 100, 200, 300, and 400. So we do that, we reinsert there. I'm going to call the for loop, and this time now size will again render 4. And it'll display 100, 200, 300, 400 again. And now finally down here, we're going to utilize the clear method just to show what that does. And so again, clear has the same effect as using the iterators begin and end up here. It'll just wipe out or remove all of the objects in my vector and clean it up. So now once again size would return 0, and that's what we would see. So if we run this, let's build the project and run it to show what it does. Okay, and I'll try to let me scroll up here, and we can step through the code as we go in the console. Alright, so resizing a vector. Notice we're displaying it. First we declare a vector and add 4 squares using pushback. So there's a pushback method. And then down here we call our for loop, and that's where we display the values. So here's our for loop, and then let me drag this up here. Maybe drag this down here. There you go. Okay. So you can see position, and then x starts out at 0, so 0, 1, 2, 3. And then our values were 100, 200, 300, and 400. Remember up here that we added with pushback. Okay. Press any key to continue. So we pause, clear the screen, move on to the next menu. And up here we say resizing the vector to 2 squares. We're moving the first 2 using erase. Alright, and that's what we're doing here. So when we do that, we're going to use the iterator begin. We're going to start at the beginning. Remember that was 100. We're going to go 0, 1. So beginning plus 2. So 0, 1. And that's just going to leave the last 2, 300 and 400. Well, we're resizing the vector. Alright, it's not the same as an array where, yeah, we could, change the values to 0 or something, but it would still have the same number of elements. Here we're actually resizing the vector itself. Has a different number of elements now. So size only returns 2, and the only ones left were 300 and 400, but instead of being at positions 2 and 3, now they're at positions 0 and 1, okay, because of what happened here. And again, we pause, and we're going to clear the screen. Enter to continue. And now let's move this up here. So now what happens next? Removing remaining squares using begin and end. So here are our iterators, begin and end here. And when we do this and we call the for loop, there's nothing to display because this has a value of 0. Well, x is already 0, so there's nothing's going to happen there. There's nothing to display. It's already the sentinel value, or the condition has been met. We're going to pause and clear the screen. So hit a key to move on again. Now we're going to add the squares back. This time we're going to use the insert method instead of pushback. And the arguments, or the argumentation's a little bit different, the way the parameters work. But if we don't want to use begin, because if we did, instead of 100, 200, 300, 400, it would go in reverse, like 400, 300, 200, 100. But from the end, we'll pop them one on top of the other, and we're going to insert at the end here, and then that, this way this will go, and then this one will go after, and that one will go after. We only want to do it one time, and then the values 100, 200, 300, 400. So when we do that, we come down here and we call this for loop. And when we call the for loop, size now once again returns the value 4, and look at the value at each position in the vector, each element. 100, 200, 300, and 400, just like it was before. Again, pause, clear the screen. We do this. And now we're going to call the clear method, and that will wipe out all of the objects in the vector. Alright, so it wipes out all the objects inside of the vector, and when we do this, size now returns the value 0 once again. Because it returns the value 0, this never happens, and the function ends. Again, let's review some vector methods. Now let's take a look at our third example. So again, I'm going to comment out resizing a vector, and I'm going to uncomment some vector methods. We're just going to take a look at different vector methods now, and how they work and what they do. So some vector methods. Here we're going to create a vector of fixed size, and it's of the data type integer. And just like an array, I can use a subscript value to assign a specific value at each position or location inside the vector, each element. And I'm just going to call the different methods here. So we're going to call max size, and that's the maximum elements that any vector would be allowed. So, I'm going to call size, which is the number of elements in the vector. We've already looked at that. I'm going to call capacity, which is the current capacity of the vector. And then I'm going to call empty, and it just returns Boolean. So if it is empty, true, and if not, not true. So empty or not empty, I can just, basically display a string value here. It's a shorthand method of saying if empty is true, display empty. If it's not, display not empty. Okay, so just different methods, and if we run this next function, let's see what it looks like. Max size, here's the size 5, the capacity is 5, and until we push another object onto it, put with pushback, and then empty, it's not empty. It has objects inside of it, in this case 5 square values. Now let's take a look at building a vector on the stack. Now let's take a look at the next example. And so once again, I'm going to recomment this third function, and we're going to uncomment the fourth. And now we're going to look at a vector on the stack of objects, okay? Vector on the stack of objects. So we can build things on the stack, we can build things on the heap. Let's see what the differences are. So here's a vector being built on the stack, and declaring a vector on the stack of Platinum Dragon objects. So in this case, the data type, right, my vector, is going to be used to contain or hold Platinum Dragon objects. And in this case, we're going to call it, the instance name is Dragon Family. And when we instantiate it, it's going to be declared to hold 2 Dragon objects. So there's going to be a mommy and a daddy, and this is how, just as if this were an array, I would use the subscript value, and it were on the stack, and I'd use the dot operator to call an accessor method or function. Well, that's what we do here. Remember our Dragon class up here? I'll scroll up to the top and we'll take a look at it. But remember that we had 2 private data members, name and age, public accessors, and we had a display stats function which would render the dragon's name and age. So if we come down here, we built our vector on the stack, and just like an array, we can use the subscript value in the dot operator to set the name and age for each dragon. So 0 and 1, that's the first dragon, the second dragon, set its name and its age. And now we say 2 platinum dragons get together and make a beautiful love child. Where there are 2, now there are 3. So now we're going to build a third platinum dragon. We'll call it baby on the stack. We'll set the name and the age. And we're just going to use pushback. And so we're actually going to modify or change the size of the vector. Now we couldn't do this with an array. We can't modify the size of an array, but we can with a vector. So now instead of 2, now it has 3 elements, or it can store 3 objects. And so if we were to call the size method, it's going to render 3, which means this for loop would iterate 3 times. And if we use x to mark the subscript value, we could say introducing platinum dragon number, and it'll count instead of 0, 1, 2, 1, 2, 3, and we'll simply call display stats for each dragon. So basically it'll introduce mommy, daddy, and baby dragon, or nice little dragon family there. So let's build it and run it. Alright, and notice the calls to the constructor and destructor. So if I come up here, declaring a vector on the stack of platinum objects, and we're building a platinum dragon, destroying a platinum dragon, building a platinum dragon, destroying a platinum dragon. As we build the vector, 2 platinum dragons get together and make a beautiful love child. Where there were 2, now there are 3. So now I'm going to build a platinum dragon, and that's the baby. Now destroying a platinum dragon, calling the destructor, constructor. Inside the for loop, we're going to iterate 3 times, and Platinum Dragon 1 is mommy, age 725. Platinum Dragon 2 is daddy, age 1085. Platinum Dragon 3 is baby, age 1. And now we're calling the destructors once again. So creating a vector like this is not the most efficient way to do it. Notice all of the calls to, unnecessary calls to the constructors and destructors of the objects here. Now we are going to build a vector on the heap that contains objects. Now let's take a look at the next example. I'm going to scroll back up here, and we will comment out a vector on the stack of objects, and let's uncomment a vector on the heap of objects. And again, an object built on the heap can be accessed and its memory managed a lot of times more efficiently than an object that is built on the stack. So let's see how the code changes for that. So instead of a vector on the stack of objects, we're going to have a vector on the heap of objects. And how does that work? Declaring a vector on the heap of Platinum Dragon objects. Well, this time, remember, anything on the heap has to be accessed via a pointer. So we have a vector of Platinum Dragon objects. Our pointer will be called pDragonFamily. And we're going to instantiate a new vector that can hold 2 Platinum Dragons on the heap. Well, because of it being on the heap and being accessed via a pointer, we have to use the arrow instead of the dot operator. So the syntax changes significantly in this example. Up here it worked pretty much like an array built on the stack, just using the dot operator and the subscript value. But here we can't do that. Here we have a vector on the heap of objects, and so what we have to do is take the pointer and we use the arrow, and then we have to use the function or the method at to get a particular object at a certain subscript value. So instead of the square brackets and just the number, we have to call the method at via our pointer to the vector. And then once we do that, then we can actually call the accessor method setName, setAge, setName, setAge. Alright, so just notice the difference in syntax here. Using the arrow here to access our a method of our vector on the heap, and then using the dot operator here to call the accessor once we've used the at method to get that object in the vector. Same thing down here, 2 Platinum Dragons get together and make a beautiful love child. Where there were 2, now there are 3. And now we're going to build a baby on the stack just to show you that we can do this. And when we do this, we're going to push back and add baby. And even though that was on the stack, we can go through and we can access via a pointer, via the arrow, and the at method, and then the dot operator, all of those objects. Okay? So, and again, we're just cleaning up at the end here. We're deleting our pointer so that we clean up our memory. So if we rebuild the project, let's see how that works. So the first time we did this, it was the stack. Now we're doing it on the heap using a pointer and the keyword new. Okay? And I'm going to come up here and again call to the constructor, call to destructor, call to constructor, call to destructor. And that's when we're creating the vector that can hold 2 Platinum Dragon objects. Okay? And then 2 Platinum Dragons get together and make a beautiful love child. Where there were 2, now there are 3. So now we build the baby on the stack, constructor, destructor, destructor. Inside the for loop it works just the same. Mommy, daddy, and baby, and the ages. And then 4 calls to the destructor down here. So the copy constructor is being implemented, the default copy constructor, and this, again, if you look at all the calls to the constructors and destructors, this is not necessarily the most efficient way to do it, albeit better than building objects on the stack. Now we're going to build a vector of objects that are on the heap. And now let's look at the next example. So again, I'm just going to comment this out. A vector on the heap of objects. And this is a little bit different. I tried to word it differently so I can illustrate. Again, this is one of those situations where the difference is subtle. You don't always notice it at first, and yet the impact is profound. So instead of a vector on the heap of objects, we have a vector of objects that are on the heap. So let's take a look at that function. And this is a bit more efficient way of doing things, as you'll notice when you look at the number of calls to the constructor and destructor. So a vector of objects that are on the heap versus, let me scroll up here, a vector on the heap of objects. So here we had a pointer, and we built the entire vector of objects on the heap. Okay, that's what we did previously. Well, what's different is we have a pointer, but we're building all of the Platinum Dragon objects on the heap, and so the data type, instead of taking an actual Platinum Dragon like we did here in the vector, we're going to take a pointer to a platinum dragon here in our vector, okay? So rather than an actual platinum dragon, it's a pointer to a platinum dragon, and it's initially going to have the size of 2. So we build our vector, and now, because of the way we're doing this, just like with an array, we have to populate the vector, just like you'd populate an array. We don't want to end up having a null object. So we have to instantiate or build a new platinum dragon inside of a for loop. And right now size would return the value 2, so we'll do that, and we'll store it in element 0 and element 1. We're going to set the attributes, and again, look how this works. It's kind of cool because it works just like an array of objects on the heap. Instead of the dot operator, we use the arrow for the end direction and just a subscript value on the vector. 2 platinum dragons get together, make a beautiful love child. Where there were 2, now there are 3. Now we're going to build our baby platinum dragon also on the heap. Set its attributes, again using the arrow. We're going to use the pushback method, so that even though we only had a vector that had 2 dragon objects, platinum dragons, now we're going to have a vector that can hold 3. So we'll push back and we'll add the baby dragon into our dragon family. Now size will render 3 instead of 2. We're going to loop through and we're just going to call display stats. And I kind of like this method for 2 reasons. One, I think the syntax is a bit more elegant and simplified. It's not as cryptic or difficult to follow. And also, you'll notice when we run it that there are fewer calls to the constructor and destructor. And finally, again, we need to call delete and clean up all of our objects on the heap. So again, for each of those dragons, we're going to call delete and free up the memory. So let's rebuild our project and test it. And personally, I just kind of like the way the code looks better when you do things that way. When we build, as we said, a vector of objects that are on the heap, as opposed to a vector on the heap of objects. And if we run it, here's what it looks like. Okay. And if you notice that there are much fewer calls to we're only calling the constructor twice here, whereas in both previous examples before we did this, there were unnecessary calls to the constructor and destructor. So there's mommy dragon and daddy dragon, and then there's baby dragon inside the for loop, and then simply 3 calls to the destructor. So this is kind of a more efficient way of doing things. There's so many different ways you could use vectors and apply vectors, but this method would be more efficient in terms of building objects on the heap and reducing the number of calls to the constructor and destructor, and also maybe simplifying your code a little bit and making things a little bit more understandable for people, your teammates. If you're working on a team project, you want to create code that's kind of easy to read, easy to follow, logical, not overly cryptic.